This fascinating aircraft was developed by Chance Vought, a division of the massive United Aircraft Corporation. It was first revealed to the public in June 1946. Anyone who laid eyes on this airplane couldn't help but come up with funny nicknames for it. They called it the flying frying pan, the skimmer, the flying pancake, the half-baked pie, the flying saucer, and a whole bunch of similar names. But don't let its downright bizarre looks fool you. In reality, the XF5U-1 was an extremely formidable and serious combat fighter. And the story behind its creation went something like this. Way back in the early 1930s, renowned American aerodynamicist Charles Zimmerman was running a series of experiments. He used very short yet incredibly broad low aspect ratio wings. His theoretical research showed that this kind of unconventional shape could actually be highly efficient. The basic idea was to mount propellers right at the very tips of this unusual wing. These props would rotate in the opposite direction of the wingtip vortices that naturally form during flight. Thanks to this clever trick, aerodynamic drag dropped dramatically. Meanwhile, the airplane's overall aerodynamic efficiency basically quadrupled. In simple terms, this meant you could build an aircraft with a fantastic speed range. Massive, slow-turning propellers paired with powerful engines would allow this airplane to hover in midair. It could even take off vertically, just like a helicopter. Meanwhile, its extremely low drag profile would let it accelerate to the top speeds of a true fighter. Inspired by this concept, Zimmerman built his first manned prototype. The aircraft was powered by two air-cooled Cleone engines, putting out a combined total of 25 horsepower. Interestingly enough, the pilot was supposed to lie prone right inside the wing fuselage structure. However, this early prototype never managed to get off the ground. The designer just couldn't get the two propellers perfectly synchronized. By 1935, he officially patented his amazing aircraft. But the inventor didn't give up. He built a much smaller rubber-powered model with a wingspan of about 1.5 feet, and it flew incredibly well. This finally caught the attention of the experts at the National Advisory Committee for Aeronautics. They had previously dismissed Zimmerman's designs as being too far-fetched and way ahead of their time. In the summer of 1937, the talented designer was hired by Chance Vought. The company was run by Eugene Wilson at the time. With access to state-of-the-art labs, Charles built a new electric-powered model called the V-162. It had a wingspan of just over 3 feet. This miniature aircraft completed a whole series of successful test flights right inside a massive hangar. The original patent was designed to carry a pilot and 2 passengers. And that is when the military started taking a serious interest in his work. In early 1939, the United States Navy announced a competition to develop an unconventional fighter aircraft. Alongside Chance Vought, companies like Curtiss and Northrop also entered the race. With funding secured from the Navy, Charles started working on a lightweight proof-of-concept aircraft called the V-173. The V-173 featured a pretty complex wooden airframe covered in doped aviation fabric, though the cockpit and propeller nacelles were made of aluminum. The heart of the airplane consisted of 2 synchronized Continental C-75 engines. Through a gearbox system, they spun massive 3-bladed propellers with a whopping diameter of 16.5 feet. Just picture these dimensions for a second. The wingspan was 23 feet and 4 inches. The total wing area was 427 square feet. And the overall length of the aircraft came in at exactly 26 feet and 8 inches. To keep things simple during early testing, they opted for fixed landing gear with basic rubber shock absorbers. Controlling this saucer-shaped aircraft was pretty unique too. For yaw control, it used twin vertical stabilizers with rudders. But for pitch and roll, they relied on large moving surfaces on the trailing edge of the wing. This is what we know as elevons. Because the V-173 concept was so radical for its time, engineers decided to test the design in one of the world's largest wind tunnels at the famous Langley Field. They did this before ever taking it to the skies. These ground tests wrapped up successfully in December 1941. The airframe proved its structural integrity. This meant it was finally time for actual flight testing. After a series of short taxi runs and cautious hops at the factory airfield in Stratford, Connecticut, the company's chief test pilot, Boone Guyton, finally took the experimental V-173 up for its maiden flight. This took place on November 23, 1942. That first flight lasted just 13 minutes, but it was plenty of time to spot a serious issue. The aircraft was physically exhausting to fly, especially during roll maneuvers. The stick forces were just way too heavy. Fortunately, the engineers quickly figured out a fix. They added special counterweights. They also rigged the system to automatically adjust the propeller pitch based on engine RPM. After these tweaks, it handled like a completely different aircraft. It became surprisingly responsive and smooth to fly. Guyton happily noted that the pilot could now deflect the stick a full 45 degrees without any major physical effort. Even though the project was highly classified, the bizarre-looking aircraft flew well beyond its home airfield. It became a regular sight in the skies over Connecticut, but another issue soon popped up. With a gross weight of just over 3,000 pounds, two engines producing a combined 160 horsepower simply left the aircraft underpowered. Due to occasional engine failures, the V-173 had to make a few emergency landings. Once, during a forced landing on a beach, the airplane actually nosed over. This happened when its small wheels dug into the loose sand. But every single time, two things saved both the pilot and the aircraft. These were its incredibly low landing speed and the ruggedness of the design. The plane never suffered any major damage. Over time, some legendary aviators joined the test program. These included Richard Rick Burroughs and Charles Lindbergh himself. They all agreed that the biggest flaw of the V-173 was the abysmal forward visibility from the cockpit. While taxiing or starting the takeoff roll, the pilot could barely see a thing directly in front of them. The unique geometry of the airframe was to blame. On the ground, the aircraft sat at a steep 22-degree nose-up angle. To try and fix this, engineers raised the pilot's seat. They even cut an extra window to provide a better view down and forward. Still, it did not quite deliver the results they were hoping for, and ground handling remained tricky. Up in the air, though, the aircraft was an absolute marvel. To get off the ground, it needed a takeoff roll of under 200 feet. And if it caught a 30-mile-per-hour headwind, the V-173 could lift off almost vertically. This was much like a modern helicopter. It had a service ceiling of 5,000 feet. It could also hit a top speed of 138 miles per hour. Parallel to these exciting tests, the engineers at Chance Vought were already looking ahead. They were starting work on an operational combat fighter. They had actually secured a development contract from the U.S. Navy back in the fall of 1941. This happened right after the military greenlit the V-173 wind tunnel testing at Langley. This new, much more powerful, and highly ambitious project was given the factory designation VS-315. The wind tunnel tests successfully wrapped up in early 1942. Right after that, the Navy Bureau of Aeronautics asked the developers for a detailed plan. The goal was to build 2 full-scale prototypes and an additional scale model for further research. By May, all the technical documentation was completely finished. Right around that time, an incredibly talented young engineer joined the team. His name was Eugene Pike Greenwood, working under Chief Designer Charles Zimmerman. He was tasked with the most critical phase. This was designing the actual airframe of the future combat aircraft. In the summer of that same year, the finished design was handed over to the Navy. The fighter then received its official designation, the XF5U-1. The most fantastic feature of this fighter was its performance envelope. The ratio of its top speed to its stall speed was an astonishing 11-to-1. For comparison, standard fighters of that era had a ratio of no more than 5. According to the engineers' calculations, the new XF5U-1 could crawl through the air at just 20 miles per hour. It could then accelerate to a blistering expected top speed of 460 miles per hour. But to turn these incredible specs into reality, the engineering team had to overcome some massive design hurdles. For example, at extremely low airspeeds, the aircraft required a very high angle of attack. During testing of its predecessor, the V-173, uneven airflow caused severe vibrations. These vibrations threatened to tear the airframe apart. To solve this problem, Chance Vought teamed up with Hamilton Standard. Together, they created a unique articulated propeller system. It featured intricately shaped wooden blades with wide root cords. These blades were attached to sturdy steel hubs and a complex pitch control mechanism. Thanks to this setup, the pilot could cyclically adjust the blade pitch right in mid-flight. This kept the aircraft perfectly stable even at the absolute lowest airspeeds. Pratt & Whitney also stepped in to develop the power plant for this radical aircraft. The engineers at the firm designed special mechanisms for the twin R2007 radial engines. This included a specialized cross-shafting gearbox and a clutch system. It allowed either engine to be instantly decoupled if it overheated or sustained battle damage. This safety feature ensured the remaining engine kept both propellers turning. Engineers also had to design an entirely new fuel system. It was capable of providing a steady flow of fuel, even at extreme angles of attack. This included angles up to 90 degrees. This allowed the aircraft to literally hover in mid-air like a helicopter. Externally, the new XF5U-1 closely resembled its predecessor, the V-173. The flight control system was also carried over with minimal changes. The construction materials, however, were a major leap forward. The main structure was a blended wing body design. It was built using a proprietary material called Metalite. This was a composite sandwich featuring a lightweight balsa wood core. The core was bonded between two high-strength aluminum alloy sheets. This gave the airframe exceptional structural rigidity while keeping the weight strictly controlled. Despite the radial engines being completely buried inside the airframe, mechanics still had excellent access to them for routine maintenance. For armament, the Navy planned to equip the fighter with 650 caliber Browning machine guns. There were 200 rounds allocated per gun. On future production models, the plan was to swap the machine guns. They would be replaced by 4 powerful 20mm ANM2 cannons. The engineering team presented their full-scale wooden mock-up of the XF5U-1 to a Navy review board. This presentation happened on June 7, 1943. At the time, the mock-up was fitted with 3 blade propellers. The Navy raised several concerns, so the design had to be tweaked a bit. But due to unexplained bureaucratic delays, the updated contract was held up. The contract to build the actual flying prototypes was not signed until a year later. It was finally signed on July 15, 1944. They decided to equip the first flying prototype with the previously mentioned Pratt & Whitney R2007 radial engines. They produced 1,350 horsepower on takeoff. The plan for the second prototype was to install XR2002 engines with Wright turbo superchargers. Naturally, the first test aircraft was completely unarmed. The official rollout of the first XF5U-1 prototype took place on August 20, 1945. By that time, the company had already received official clearance to conduct flight tests. These tests were to be held at the Muroc Dry Lake Test Range in sunny California. However, the budget was getting extremely tight. Back in the spring, Vought had asked the Navy for additional funding. This was because the initial budget for the project was completely depleted. To save cash, the engineers had to drastically scale back the test program. They reduced both the number of test flights and the static ground tests. The aircraft was temporarily fitted with 4-blade Hamilton standard propellers. These were the kind typically used on the famous F4U-4 Corsair. With these installed, the XF5U-1 successfully carried out its engine runs and taxi tests. Meanwhile, the second prototype was used exclusively for ground structural testing. Eventually, the first prototype was fitted with its own custom-designed articulated propellers. The skimmer, which was the nickname the engineers gave the aircraft, showed incredible promise during ground testing, but it never actually took to the skies for a real test flight. Test pilot Boone Guyton conducted a series of high-speed taxi runs and brief hops off the runway in early 1947. While it never flew, calculations showed that with the planned turbocharged engines, the airplane could have achieved absolutely fantastic capabilities. The design projected a blistering top speed of around 460 miles per hour. It was also designed to take off vertically from a special trapeze rig with its props pointed straight up, and to hover in mid-air much like a helicopter. Before long, the skimmer was packed up and prepped for a long sea voyage. It was supposed to travel through the Panama Canal out to California. But then, the unexpected happened. On March 17, 1947, the program was abruptly canceled. There was one main reason for this tough call. A new era of aviation was dawning. The United States Navy was facing severe post-war budget cuts and was actively transitioning its limited funds to jet aircraft. This meant an expensive, delayed piston-engine fighter had simply lost its relevance. The end of this story turned out to be pretty tragic. Under strict orders from Navy brass, all the most valuable equipment was stripped from the prototypes. Then, the unique airframes themselves were ordered to be destroyed. But the Metalite construction proved so incredibly strong that standard bulldozers couldn't crush them into scrap metal. Ultimately, crews had to use a heavy wrecking ball dropped from a crane just to break the airframes apart. Fortunately, its predecessor, the V-173, had much better luck. Around that same time, it was transferred to the Smithsonian Institution. This amazing aircraft is still preserved there today, serving as a reminder of those bold engineering dreams. To briefly break down the design itself, the XF5U-1 fighter was a highly unusual twin-tail monoplane. Its fuselage and wings blended smoothly into a single lifting body. Its wing had a perfectly elliptical planform and a completely symmetrical airfoil across the entire span. This is exactly what made it look so unique and futuristic for its time. If you look at the design of this aircraft, you can basically break it down into three main sections. Up front was a spacious cockpit, air intakes with fans for forced engine cooling, and the gun bays. The center section of the fuselage was built around a sturdy internal framework. This is where engineers placed the heart of the aircraft, the engines. They were housed along with the fuel tanks and a complex system of drive shafts transferring power to the propellers. The main landing gear struts were mounted to the bottom of this frame, and out back in the tail section were the main flight control surfaces, a small tail wheel, and an arresting hook for carrier landings. The internal skeleton of the aircraft was built from lightweight, yet durable aluminum alloys, but the most interesting part was the outer skin. Vought used their patented, innovative material called Metalite. Picture a composite sandwich. A layer of ultralight balsa wood was placed between two thin sheets of aluminum. This was then securely bonded and pressed together under high pressure in a massive autoclave. This material was so incredibly strong and rigid that designers could significantly reduce the number of internal supports. As a result, the airframe essentially became a single continuous structure like a rigid shell. The cockpit was fully pressurized and enclosed by a clear bubble canopy that slid back electrically. For emergency bailouts, it was fitted with a Martin Baker ejection seat. Right in front of the pilot was the main instrument panel. It housed all the key gauges for navigation and for monitoring aircraft systems and engine performance. To the left of the pilot were the engine throttles and propeller pitch controls. There were also levers for the landing gear and arresting hook. The right-hand console, meanwhile, was entirely dedicated to circuit breakers and the radio control unit. Powering the aircraft were two massive 14-cylinder Pratt & Whitney R2000 twin Wasp engines. They cranked out 1,350 horsepower each on takeoff. Mounted to the front of each engine was a gearbox. This gearbox transferred power to a shared drive shaft, which in turn spun the propellers. This mechanism also drove the engine cooling fans. Hot air would then exit through adjustable louvers on the top and bottom of the fuselage. Meanwhile, the exhaust gases were routed out underneath. If an engine failed, the pilot could instantly decouple it from the drive system using a clutch. This allowed the aircraft to remain controllable. The massive propellers themselves featured wooden blades. They also had a complex variable pitch system for better flight maneuverability. The landing gear consisted of 3 struts. Each was equipped with dual wheels, including the tail wheel. They retracted into the fuselage hydraulically. The aircraft sat at a steep, nose-high angle of nearly 19 degrees on the ground. Because of this, engineers had to take an unconventional approach. They mounted the arresting hook right on top of the fuselage. It was also hydraulically actuated. The flight controls of the aircraft were strictly mechanical, utilizing rigid push rods. To pitch and bank the aircraft, it used all moving control surfaces on the tail. These were stabilators that could deflect independently of one another. To maintain directional stability and prevent adverse yaw, designers installed 2 large trapezoidal vertical fins with wide rudders. Additionally, automatic flaps were integrated into the tail section. These were absolutely critical during landing to help counteract ground effect. Ground effect is a cushion of air building up under the aircraft, which can make it difficult to touch down smoothly. Communications and navigation were handled by a shortwave radio and a radio compass, with their antennas neatly tucked away under the belly. The initial XF5U-1 prototypes weren't fitted with any weapons at all. but a serious arsenal was planned for production models. 6 50-caliber Browning machine guns with 400 rounds per gun, or 4 powerful 20mm cannons. Hardpoints were also designed under the fuselage, allowing you to sling up to 1,000 pounds of bombs or 150-gallon drop tanks to significantly extend its range. However, there was one major problem. Because of the massive propeller arcs, the fighter couldn't fire unguided rockets or drop bombs in a steep dive. The munitions would simply blast its own blades to pieces,